Hi everyone, hope everyone is okay. Welcome to the Mr. X free class as we prepare for our June exams. We are going to be touching on the topic of functions with particular emphasis on the hyperbola, the parabola, the exponential, as well as the straight line. So we are doing questions that will help us to prepare adequately, to know the basic concepts, to know the difficult concepts over and over again as we go through today's lesson. Very importantly, just to let you know who I am, my name is Kolani, but most people will call me Mr. X. I run through an online platform of teaching where I do grade 11s and grade 12s, usually on Mondays. We have classes 7 p.m. to 9 p.m. for grade 11 maths, Wednesdays 7 to 9 p.m. for grade 11 physical sciences. For the grade 12s, Tuesdays and Thursdays, those are the classes. So the classes are 5 classes typically every month. So every single week we do a class and it's 250 rands per subject. That's very important. It's 250 rands per subject. If you want to do 1, 250. If you want to do 2, it's just going to be 500 rands. So these classes started as far as Feb. So we've been doing them up until now. Great times that we have as we're learning and pulling through. But very, very importantly, we have the June exam revision classes coming up for our grade 12s, and also we'll do the grade 11s. I will update on the information of the grade 11s in my WhatsApp groups. These June classes are going to be 10 hours for each subject. 10 hours for each subject. 10 hours revision maths, 10 hours revision physical sciences. These are the dates and these are the times and those are the topics that are going to be happening. It's going to be massive as we learn, prepare ourselves, because I tell you this, you want to get into the exam fully prepared for what you are getting into, knowing the ins and out. You do not want to get there confused. So take this opportunity, 200 rands for the 10-hour revision. So for one subject, physical science, 200 rands, 10 hours. For another subject, mathematics, 200 rands, and also it will be 10 hours. These are the dates, take note. So if you're interested, my number's there. You can contact Mr. X on his number, then you can take it up from there. On top of that, we do have the normal weekly classes which are currently taking place. So this is the schedule that you're looking at. It's those classes I was talking about when I said it's 250 rands for these 5 classes, covering both grade 11 content and grade 12 content for both mathematics and physical sciences. Take time and learn. The students that come to these classes will tell you we're learning, they are passing, they're improving. Mr. X, they usually say, can save you time. Lastly, you can find me on YouTube under the Mr. X Mathematics and Physical Science channel name. You can find me also on TikTok as Mr. X, where I post a lot of videos, short videos when I'm teaching physically, and people can see me explaining the different concepts that we have and that we're supposed to know. So that's basically who I am. I'm excited about what's going on. Let's do our thing. Welcome to school. Let's do functions. Let's do this. Our first question is the 2024 KZN June paper 1, and it's question number 3. What it will help you to do is maybe write down the title. We work together. During the course of the teaching, the lesson, you can always ask questions where you do not understand. I want to begin and we start off. 2024, get your books out, your pens out, everything out. Me and you on fire. Let's do this. It goes. The function g is defined as g of x is equal to half to the power x minus 4. I want you to know that when it comes to functions, every typical function has its own unique equation. So if you're speaking about an exponential function, it has its own unique equation. And if you're speaking about a parabola, a hyperbola, or even a straight line, every typical function has its own unique equation. Just by reading the equation, g of x is half to the power x minus 4. This should remind you that this is a typical exponential function, which is usually written in this format. So it says the function g of x is half to the power x minus 4. Fine. Our first question says write down the equation of the asymptote of g. Write down the equation of the asymptote of g. When you talk about the original, typical original exponential function, this value of q, this long term, so here in the context of the question, it's half to the power x minus 4. This long term right here is your asymptote. So in an exponential function, we concentrate on the y asymptote, which in this case would be this number, -4. So when 3.1 comes through, write down the equation of the asymptote of g for 1 mark. It is the value of q. It is this long term. It is the y asymptote, which is y is equal to -4. So just knowing that would give you 1 mark. The asymptote is the long term. It is the value of q, as can be seen right there. Let's keep working on it and pulling through together somewhere there. All right, I'm ready for 3.2. Let's do this. 3.2. 3.2 says the following. Calculate the y-intercept of g. Calculate the y-intercept of g. Now, in a graph, very importantly, the y and the x-intercepts are important coordinates. We use them a lot in sketching our graphs. So the question here says, calculate the y-intercept of g. Do note, the y-intercept is always found when the value of x is 0. So you go to the original equation, g of x, which is as good as saying y, is equal to a half to the power of x minus 4. When do I get the y-intercept? When the value of x is 0. You do your maths, half, where there's x, you put 0, minus 4. Mathematically, any number to the power of 0 is 1. You can even try it in the calculator, but I need you to remember that. In exponents, any number to the power of 0 is 1. So this is 1 minus 4, and your answer is -3. Therefore, the y-intercept, which is found when x is 0, and in this case, the value of y is -3. What is important in mathematics is that these questions, these small questions, 1 mark, 2 marks, and all, they're building up to even more information in the next questions. So you will be required to use the information that you got in the previous questions to be able to answer even the next questions that come through. I'm ready for 3.3. I think we're still moving. As always, we are winning step by step, and we are pushing through together. 3.3. You tell me. Calculate the x-intercept of g. When do you think we get x-intercepts? Come on now. You can type your answer. When do you think we are able to get x-intercepts? Yebo. We get x-intercepts when the value of y is 0. Perfect. So for our next one, x-intercepts available when y is 0. Let's do some maths. G of x, y is half to the power x minus 4. When we're looking for the x-intercept, the value of y is 0, half to the power of x minus 4. We need to solve for x. I can take negative 4 to the other side. I transpose. That's 4. Then this is half to the power of x. Now listen to me. It is important to understand that when solving exponents, you should be able to get the numbers in the same base. Now here's what's important. Right now, it's 1 over 2 to the power x. I can rewrite it as 2 to the power negative x. According to the laws of exponents, if the power is negative x, the base can be inverted. So if I say to you, for an example, 4 to the power negative 1, it can be written as 1 over 4 to the power 1. That's fine. So the 4 inverts from 4 over 1 into 1 over 4, and the vice versa is possible. So when it's 1 over 2 to the power x, it can be written as 2 to the power negative x, as can be seen. But how do you solve exponents? The bases must be the same. Nailana u4, I can change 4 to the base of 2, check, check. That's 2 squared. 2 is equal to negative x. Once you are here, the bases are now the same. You can drop the powers. So it becomes 2 is equal to negative x. Then quickly, you can make it work for you by dividing both sides by negative. So the value of x is negative 2. Therefore, the x-intercept is available when x is negative 2 and y is 0. Very important to get that right. Step by step, we're building up. Let's try 3.4. You let me know if there's any problem, but I think we're still on the right track as a team and as a family right there. Let's go for 3.5. Draw a neat sketch of G. Clearly show all the intercepts with the x's and the asymptotes. So it's important that when you are drawing a graph, you use the information that you acquired for your x-intercepts, for your y-intercepts, and even this very question says, show even the asymptotes. Let's gather the information. Y as negative 4 was my asymptote, and maybe that's the first thing I would need to put when I'm sketching my graph. You show the asymptote by a dotted line. Y as negative 4. Notice this. The y asymptote is a horizontal line. So I'm writing it as 1 dot, 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 dot. Then I write y as negative 4. I need to put my coordinates. I notice that I have the x-intercept, I've got the y-intercept, and I can quickly find my coordinates and put them into my graph. 0 and negative 3, I got it. I also had negative 2 and 0 as well. Let's do some maths. 0 and negative 3 is a sketch, probably somewhere here. Okay. Negative 2 and 0, probably somewhere here. Okay, that's fine. Now let's pause and reflect. in terms of the shape of a typical exponential graph, the shape of a typical exponential graph is influenced by the base, the number with the power. In this case, half to the power x. I want you to understand that when it comes to an exponential graph, it could either be exponentially increasing or it could be exponentially decreasing. Listen to this. If the graph is exponentially increasing, then the power, usually we call it b, because from the main equation, there we are, it is the power, this number with the power, this base. If b is greater than 1, then your graph would be exponentially increasing. If b is greater than 1. Okay, all right. If b is between 0 and 1, okay, 0 is less than b is less than 1. Just like what we have in our situation, then that graph would be exponentially decreasing. And you'll see when I draw it now, it will be exponentially decreasing. That would be the basic shape of that graph. So the shape of the graph of an exponential is due to the value with the power, the b, greater than 1, exponentially increasing, between 0 and 1, exponentially decreasing. And I'm going to draw. I'm not the best person to draw anything, but I know you'll see passes through you. Yeah, sharp. As you can see, you guys would have drawn it better. And what you can see here, very interestingly, is that this graph does not touch the asymptote. In other words, it is not available on these typical asymptotes. And just as a further way to learn, listen to this. When you're asked about the range of a graph are your y values that are permissible on this graph. So looking at what we have, and you're asked about the range of the graph, then you will see that your graph does not go below the line y is equal to -4. In other words, all your y values for this graph are above 4. That's English, maths, greater than -4 rather. So therefore, your y values are greater than the value -4 if you are asked about the range. You do not have y values below -4, neither do you have a y value on -4. The graph does not reach -4, so all your y values are greater than -4. That would be your range if you're asked in this case. Work with me. Work with me. I'm on 3.5. This was just some extra information so that it becomes easier to pull through from there. I'm ready for 3.5. Now, oftentimes when you do this topic, you will hear about average gradient. Average gradient. I did put some notes here to clarify, and I said, note, the average gradient of a function between any 2 points is defined as the gradient of the line joining the 2 points. So just like what we do when we deal with gradient, Average gradient is the same thing. You just need to get your 2 points, y2 minus y1 over x2 minus x1. That's basically it. And I'm reading question 3.5 in our hearing. Calculate the average gradients of g between x is 0 and y is 0. That's what they want. Between x is 0 and y is 0. Now hear me out. When x was 0, the value of y, I think, should have been -3. So that's the coordinate that we had, because they want it between x is 0. And we already know that when x is 0, y is -3. Further on, when the value of y is 0, the value of x is -2. And what do we need to do? Calculate the average gradient. Calculate the average gradient. Follow my lead. So gradient as we know it is always y2 minus y1 over x2 minus x1. So the y2 could be anything you can choose, but you need to be consistent. Usually this is my advice. I need to, this one is the top coordinate, the bottom one. So you can make this guy x2, this one y2. So this one will be y1, while this one is x1. And you just follow it like that. y2 minus y1, that's 0. y2 minus y1 minus 3 over x2 -2 minus x1, which is 0. The rest is algebra, and your answer for the gradient, average gradient, is -3 over 2. That becomes your answer right there. All right, perfect. That's 3.5. And let's try 3.6 quickly so that we can see what we're doing. 3.6, that was 3.5. Now let's go to 3.6. The more we do, the more we know. The less we do, the less we know. And what do we want? Would like to do more. Look at 3.6. With mathematics, you've got to get excited. You've got to love the subject. You can do this. You can pass. You can get it right. Do not be afraid. Chuck Norris, this is your thing, boy. Take it. Get the marks. Understand it. Here we go. I'm on 3.6. 3.6 says to us, write down the equation of k if it is further given that k of x is equal to g of x plus 4. So they want us to write the equation of k. Fine. G of x, from what we have, is this. So I'll write it as I see it. So it's a half to the power x minus 4. That is g of x. Then it's g of x plus 4. So there's a plus 4 as well. So eventually my answer becomes a half to the power x. I need to minus 4 plus 4 would give me 0. So at the end of the day, the equation of k of x is what you see there, a half to the power of x. I have a question here. In this case, when you're dealing with k of x, what should be the new asymptote? Now that k of x is half to the power x, what is the new asymptote? What should it be? Oh, you guys are on fire. So you people are saying, my people, are saying the new asymptote, its equation is y is equal to 0. Completely agree with you in the context of what we are doing. Let's try 3.7. Very interesting. 3.7. Here we go. 3.7 says, it is further given that h of x is 2 to the power x plus 3 minus 4. Explain in words how graph G must be transformed to obtain graph H. Graph G, as we know it, is half to the power x minus 4. They tell us that graph h of x is actually 2 to the power of x plus 3 minus 4. Then they ask us, explain in words how graph G must be transformed in order to obtain graph H. Let's do some math. So we're interested in knowing how we move from here, graph G, all the way to graph H. So let's look at some fundamental differences. Number one, the base of graph G is a half. The base of graph H is 2. Looks like it's the inverse. Sure. The x in G does not have a number. It's a 0, x plus 0. But here it's x plus 3. So now we need to explain how we are able to move from G of x into H of x. How did we move in such a way that the base was half, now it's 2, that it was x plus 0 and goes to 0, now it's x plus 3. What type of mathematics needs to happen for that to take place? Let's think. Let's start off with the issue of the base. Number one, let's do exponential laws. If you were to make x negative, the base half will flip and become 2 over 1, which is 2. Okay, say that again. If you made x negative, in other words, instead of half to the power x, it becomes half to the power minus x, then this 1 over 2 will flip to become 2 over 1, which is basically 2. Now the real question is, how do I make x negative? So here's the transformation that you would do. In maths, if you reflect the graph in the y-axis, I'll tell you this, the x values become negative. So say that again, say. So every time you reflect a graph in the y-axis, the x becomes negative. Let's see what's happening. So I will say a half, okay, where there's x, negative x. And how do I do that? It can only happen when you reflect this graph in the y-axis. And so therefore, you end up with 2. This base is 1 over 2. It becomes 2. Then this becomes x. Then minus 4. So I want you to see what's happening here. It's a half to the power negative x. It will convert to 2 to the power of x every time you put a negative to a power. In order to get rid of that negative, the base must invert from 1 over 2 into 2. Then you will put this as an x. Laws of exponents. So that's the first thing that you did. You reflected in the y-axis, where the x value becomes negative. You see, logically speaking, and let me show you something here on the side so that you can see what's going on. Right. If you have a graph, let's say the graph is like this, similar to what we did, and you reflected it in the y-axis. So let's say there was an x coordinate here, and currently it's positive. If you reflect it in the y-axis, the x value would become negative. Every time you reflect in the y-axis, the x value becomes negative. I want you to hear that out. So if this is your mirror, the y-axis your mirror, I reflect this coordinate. Currently, it has a positive x value. When you reflect it in the y-axis, it comes this side. Now it is a negative x value. So I want you to understand this. Every time you reflect a graph in the y-axis, it means that the x values of that graph will become negative. And further on, in the laws of exponents, if this is a negative power and you'd like to make it positive, then this half inverts from 1 over 2 into 2 over 1, which is 2, then to the power of x minus 4. This is the first thing that we did, but we're not done. There is the x plus 3. X plus 3. So currently, we now have 2 to the power x, but Bona, they have 2 to the power x plus 3. Now listen to this. When you say 2 to the power x plus 3, it means that you have transformed your graph on a horizontal shift. X plus 3, you are affecting your x values. X plus 3. So when you say x plus 3, it means that there was a shift of this graph 3 units to the left. Yeah, Chuck Norris, to the left. Let me write it down, what you did. In other words, you said g of x plus 3. So where there's x, you put x plus 3. Then there's obviously the negative 4. And how do we explain that in words? We say it is a shift 3 units to the left. Let me talk about the anomaly. Now, there is a plus 3, x plus 3. It means that your shift was to the left, not right. No. I know for some of us, we think that when it's plus 3, it means to the right. No. When it's in a bracket, x plus 3, you are shifting 3 units to the left. That's exactly what you're doing in the context of this question. So when you're now explaining how you moved from here, g of x, into h of x in that regard, it means, therefore, first of all, you reflected in the y-axis, the power becomes negative, the base inverts, then it's now 2 to the power x. Sorry, reflected in the y-axis, then the x becomes negative. So then after that, you then shifted this graph 3 units to the left, and eventually you now have the graph in terms of h of x. And I see that there's so much activity going on. It's always to the left, guys, all the time when it's +3. On my YouTube channel here, do check. There's a topic that I was doing on trig graphs. And I did explain the horizontal shift, the horizontal transformation. That when you're going to the left, it's a plus. But when you're going to the right, it is a minus in that regard. So that's 3.7. So in terms of the explanation, you would say, number one, I reflected the graph in the y-axis. Number two, I shifted later on 3 units to the left. That's what you have, Chuck Norris. Let's keep working. Let's try another question, another graph over and over again until we fully understand what we're pulling through. Somebody says, so you'll say you made it simple. Thank you, boy. That's how we roll with Mr. X, and we learn together. Let's try 2014 standard grade. What an interesting question. So 2014 standard grade paper, and it's question 3.1 up to 3.1.4. Let's get on to that. Work with me. We are moving together. Now, just as a heads up, in almost all the questions, you are going to have a situation where it's not just one graph. You could find several graphs inside a typical question. And here we've got 3 different graphs. And I want us to work on them together. It's important to pull through and we take it up from there. Here's the story. The diagram below, which is not drawn to scale, represents the graphs of, number one, a parabola f, which cuts the y-axis at -2 and passes through the point P, which is -1 and 1, as well as Q, which is 2 and -2, and also has a turning point at R. So we do have a parabola. Look at the next point. It says there is a straight line. Okay, a straight line G that passes through the point Q and the point R. Sharp. Then finally, there is a hyperbola. Okay, which is restricted for h of x less than 0. And that hyperbola passes through the point P. Everything that they said is available on the graph. So we've got 3 graphs here. A parabola, so our mind must think about it. A straight line, our mind must think about it. But a very interesting hyperbola where h of x is less than 0, passing through the point P. Our first question for 6 marks. Show that the equation of the parabola is actually y is x squared minus 2x minus 2. Let's work together on this one. Now, when it comes to a parabola, the other name would be a quadratic graph. There's 3 equations that you can use, but they all depend on the information that has been given. So there's what is called the standard format, where you say ax squared plus bx plus c. Now, just briefly, the value of a gives you the shape of that graph. It will tell you if the parabola is a happy one, like for an example, ours is smiling, it's happy, it's at its best time of its life, going through the best times. A would be positive. And even from what they asked us to show, the a value, which is the coefficient of x squared, is a positive 1. It's a ghost 1, but it's positive. Also, very importantly, is the value of C. In a typical parabola, the value of C is the y-intercept. It's the y value when the graph is cutting the y-axis. So say that again. Say, who is C? The y-intercept. I'm going to write it properly here. That's the value for C. And this will help us to start off our question. C, the y-intercept. From what I'm given here, I'm working on my 6 marks. From what I'm given here, I can see that this point, -2, where x should be 0 and y, -2. This -2 is actually your C, is actually your y-intercept. And you can see it even in the format that they want, -2. So that's the first thing that we're getting. C in a typical parabola is the y-intercept. So let's contextualize this. When we contextualize, it will now be y is x squared, okay, plus bx, all right. Where there is C, would put the -2, -2. So this is what I have currently. Now, mathematically speaking, work with me. Mathematically speaking, when you've got two unknowns, I don't know A, I don't know B, you can solve them simultaneously. So let me go back to my graph and see if there's further information that I have. I think I have the point P. The point P is available on H, the hyperbola, and F, the parabola. So I can use it. Also, I have the point Q. It's available on G, the straight line, and F, the parabola. So these coordinates are available on this parabola equation. So I can safely substitute P, safely substitute Q, then try and solve them simultaneously. Already I know C due to the fact that it is a y-intercept. So let me do my maths. Work with me step by step. So I can put P, which is -1 and 1, and see how far it goes. So where there's y, -1, algebra right here. Let me put it underneath here. So P, -1 and 1. So where there's y, -1. Then A, where there's x, I will put 1 plus B, where there's x, I put 1 minus 2. We do the maths, -1. 1 squared times A is A, B times 1 is B, then minus 2. Part of the revisions that I will do is for the grade 11s, and we're going to do a lot of algebra, functions, trig, and all, and I'll update on the revisions for the grade 11s. So do look out on my social media pages as well from there on. I can do the maths together here at the end of the day, so you will see what's going on. So no, the x value should be -1. Sorry about that. And the y value should be 1 there, so that I can get an answer which is working. Again, it will get you the same place. So this should be -b. Sorry about that. Check this out. I can take -2 to the other side. This gives me 3. So that means A minus B would give me 3. And I can make B the subject of the formula if I want, or I can just call this equation number 1. So let's do some algebra here. Let me make B the subject of the formula. So I'll take it the other side. So B is now A minus 3. That's equation 1. This is when I just substituted P, but I can also substitute Q. So let's try that with Q. So this time with Q, and Q is 2 for X, negative 2 for Y. Where there's Y, negative 2. Where there's X, positive 2, that's squared, plus B, that's 2, minus 2. You guys will help me to get the algebra right this time. Work with me. Negative 2. That gives me 4A plus U2B, then still minus 2. I think I can take minus 2 to the other side. It'll give me 0 is equal to 4A plus 2B, and I can call this equation number 2. So now I've got my two equations there, 4A plus 2B. If you want, you can further divide this. Let me show you the maths. I can divide everything by 2 so that it becomes 0 is 2A plus B. I can do that so that I can at least even further make B the subject of the formula. See what I can do? Let me show you. So I can make B again the subject of the formula here if I want, or let me just leave it like that. Call this equation 2 so I don't confuse you. Then now we've got our two typical equations and we can solve them simultaneously. So usually we would say take equation 1 and put it into equation 2. In other words, where there is B in equation 2, we will put A minus 3. So let's do the maths. 0 is equal to 2A. Where there is B here, it's A minus 3. We do the maths. I'll take negative 3 to the other side. It gives me 3. Then 2A plus 3A plus A is 3A. That means the value of A eventually would be 1. There it is. A is 1. Then to find B, we can use equation number 1 because now we know what A is. So A is 1 minus 3, then minus 2. So true to what they wanted. The value of A, net 1, B, negative 2, C, also negative 2. Therefore, finally, the equation of the parabola would be y is x squared minus 2x minus 2. And that's very important to understand. So I think you guys are on fire. You're helping me. We're helping each other. We're pulling through together and we move through from there. So listen to me. Listen to me. Now, in essence, this is what we're doing. And I'll repeat this so that you can see what's going on. When given a typical set of information, when you're given information just like this, and you are looking for certain values, you're going to use what you have to find what you do not know. Very key to this is that the value of C is the y-intercept, which is negative 2. That was the first most important thing. Further on, when you have written your equation in this way, ax squared plus bx, we do not know what A is. Neither do we know what B is. But we know that the points P, negative 1 and 1, and the points Q, 2 and negative 2, lie on this equation. So I will simply substitute OP, where the x value is negative 1, -1 and the y value is 1, I form an equation and I made b the subject of the formula. Then further, I say to myself, if I substitute q, I form another set of equations. Then eventually, I can solve them simultaneously. I want you to know this. If you ask me what the most important topic in maths is, I'll tell you. Algebra. Plus, minus, divide. Those small little things, they are everywhere. And you need to be careful as to how you handle them. So algebra is super, super important in helping you to answer the questions that you require. I want to move through right there. Perfect. So you have many options. Somebody's asking what to say on the second equation, would I be wrong to make b the subject of the formula? My answer is you would not be wrong. You can make b the subject of the formula, but when you do so, it means equation 1 is now equal to equation 2. It's not getting into, but rather it's equal because both of them are equal to b. So you would be correct to say that. I'm taking this out. Let's go. Work with me. 3.12. Let's try that one together. 3.12 says, show that r is 1 and -3. Show that r is 1 and -3. Now, there are two options to this, and I'll tell you what, it depends on which grade you're doing. For grade 11s, I'm going to show the method, and I just want that to be the one that everyone uses. I know there are grade 12s in here as well. In grade 12 language, you'd have to derive, it's a turning point, and equate to 0. But let me do the grade 11 way of doing stuff so that it is easy. Remember from what they said prior, they said the point R is a turning point. The equation is y is x squared minus 2x minus 2. Specific to the situation, A is 1, B is -2, and C is also -2. Now listen to me. In grade 11, we learned that the x value of the turning point, x value of the turning point is found by saying minus b over 2a. It'll give you the x value of the turning point, minus b over 2a. Work with me. So minus b, that's minus 2 over 2a, that's 2 times 1. You do the maths, the x value is 1, as is specified. Then to find the y value, you substitute back into the original equation. That's what you do to find the y value. You'd substitute back into the original equation right here. Fine. So then I would have to look into the original and say the x coordinate of the turning point is occurring when x is 1. So let me substitute x is 1 to see what value for y do I end up getting. Let's see that. Okay, perfect. It looks like at the end of the day, I do get -3. So the turning point, point R, is just 1 and -3. Very important to get that. 1 and -3. Like I say to you, you can always use the derivative. For grade 12s, you derive and equate to 0, solve for x, and then get it back into the original. But I want us to just do this method for today and perfect in that manner. Let's try 3.13. You let me know if there's any problems. The guys on YouTube, I'm also noting some of your questions, and I'm trying my best to pull through and answer them as we go along together in that regard. Step by step. Here we go. I'm ready for the next one. Okay, somebody has a hand up. Let's see. Guys, if you're going to ask a question, please make sure that the environment where you are is quiet so that it doesn't really disturb the flow of things. Otherwise, my preference, honestly, is that you type your question. Let's go for 3.13. Determine the equation of G in the form this. 3 marks. All right, all right. G is a straight line. Sure. And they want us to determine the equation of G in that format. Sharp. When dealing with a straight line, please note the following. In a straight line, to find the equation, you need two things. Number one, you need a point, 2 points on that line to give you the gradient. Number two, then you will use the equation y is equal to mx plus c. So let me see what I have. I do have the point R, which is on the straight line, which is 1 and -3. I also do have the point Q, which is 2 and -2. And I can get the gradient of this line, y2 minus y1, over x2 minus x1. So we can do the maths together. So I can do y2. I can always call this y2. So it becomes -2 right there, minus 3 over, so it's y2 minus y1 over x2, which is 2 right there, minus 1. Do confirm with me, but I think the answer should be 1. All things being equal. Sharp. This is what I have currently. Then to find the rest of the equation, but this format is very interesting. Usually with a straight line, we are used to y is equal to mx plus c. mx plus c. So here's the story. Y is mx plus c, where m is the gradient. I'll put it there. Then x and y is any point on that particular straight line. So I could use the point R if I wanted. I could use the point Q if I wanted. Maybe let's use R, where the y value is -3. There you are. And the x value is 1. There you are. So that's my current story. And I'm trying to find C in this regard. 1 times 1 will give me the 1, -3 plus C transpose -4 is equal to C. So here's how my equation would look like. It will be y is equal to m, which is 1, and then times x, but c is -4. Now, you don't really need to put the 1, because the 1 is like we usually call it a ghost. So this is how your equation is currently, but it's not what you have there. This format, ax plus by plus c, don't worry guys, is very easy to understand. All you need to do, Chuck Norris, all you need to do is to just make sure your expression is equal to 0. How do you do that? Transpose. Check. Y minus x plus 4 is equal to 0. Now, it is now in this format. You can even rearrange if you want and start with the x. So it's now negative x plus y plus 4 is equal to 0. Check. Your a is negative 1. Your b is positive 1, the coefficient of y. Your c, in this case, when you do that format, is positive 4. So all you needed to do was to take the equation that you currently have and just equate it to 0. You can leave it here if you want, y minus x plus 4. But I had to show you that you can rearrange because they started with ax and then also by, then also c, and all these are equated to 0. So the whole idea is to equate them to 0, and you'll be able to get what you need from there on. And that's what you do. So do not be afraid when you see these questions. Yo, what is ax? What is by? What is what? So, and all. It's not a train smash in always like this. So you'd be able to get it right by transposing from the other side, and we take it up from there. So that's how you go around it. I've explained this again, and I'm just trying to run through this, where I'm saying you're determining the equation of g, and it's a straight line, and you got 2 points, r and q. Get the gradient first. You can substitute point r or point q. Either of them will give you the same answer. In case you didn't know, either of them will give you the same answer. Then you get your C. Then you make it into the format that they wanted by simply ensuring that you transpose and equate everything to 0. You could have simply ended it there, but if you want to show them that you're going to varsity next year or whichever year, then you can rewrite it by rearranging in this particular manner. Either way, it will be like that. You just need to make sure everything is equated to 0. That's all. Either way. All right. Let's try 3.14. 3.14. Step by step, we're pulling through. And I'll tell you this with maths and maybe functions in essence. Generally speaking, the more questions you do, the more things you practice, the more things you generally kind of know. So that's why I am really in agreement, or rather, I would really love you guys to work extremely hard on doing a lot of practice questions and working it out. Weekly, me and my other students were always doing questions, learning together on the Mr. X classes. Like I said, I got your back. We win on that one. Now 3.14. Write down the equation of the hyperbola H. Let's discuss this for 2 marks. The hyperbola is given as h of x less than 0, and it passes through the point P, -1 and 1. From what we know, a typical hyperbola would be a over x plus p plus q. This is how the typical equation of a hyperbola goes. But this hyperbola is very interesting. It is restricted h of x less than 0, suggesting that all your y values, or rather all your typical h of x here less than 0, your graph is only on one side. Usually we should have this side and maybe that side, but we don't have that. at all. We just have it closed somewhere here. And that's all. And it means by extension that my y asymptote, my x asymptotes are 0. They are literally the y and x axes. This hyperbola is restricted on the y and x axis. So it can't go anywhere because the border or the boundary is the y and the x axis. That's the restriction of this typical hyperbola as we see it. There's another method to this, and I'll show it to you. But let's start here in this context. So y is equal to a over x plus p and x plus q, where p and q are literally 0. The y-axis, the x-axis, the asymptote. So this graph here is restricted on the y-axis. That means x is 0 here, p is 0. Restricted on the x-axis, that means y is 0, q is 0. So literally, it's as good as writing this. Just like that, as writing that. And they said write down the equation. So your p and your q, your y and your x asymptotes are literally your y and your x axes. Because this graph is restricted, covered, bordered, walled by these asymptotes, which are the x's right there. Very much. It means that p, it means that q is equal to 0. Fine. That's the story. The question, write down the equation. So I noticed that there's a point, -1 and 1. That point is available on this particular graph. So I can quickly substitute where there is y, 1, where there is x, -1. Then I cross multiply. That means a is -1. So finally, your equation is y, where there's a, -1 over x. And that's all. And just by looking at it, it is true to what we were saying. The y asymptote 0, the x asymptote 0 as well. Because literally at the end of the day, you are going to have a situation whereby you do not have the y and the x asymptote. That is very, very important. They're actually 0 in that context. So the border or the boundary are the x and y axes. Please remember this, and I'm just going to repeat this to make it a bit more clearer. The y-axis, at the y-axis, the value of x is 0. At the x-axis, the value of y is 0. So this graph, restricted in this manner, shows me that the x value of the asymptote is 0, which is literally the y-axis. And similarly, this graph, according to the boundary that it has, shows me that the y-asymptote is 0, which is literally the x-axis. So where there is x and y, I substituted the coordinate that is available, cross-multiplied, got my a as -1. So where there is a, now I know ukuthi a -1, and eventually my equation for the hyperbola is y is -1 over x, right there. And I think I've tried to pull through with the explanation one more time so that people can be able to see what's going on. All right, perfect. So remember again, guys, the boundary, the asymptotes are the x-axis, both P, both Q, they are all equal to 0. The x asymptote is 0. The y asymptote is 0 as well. And eventually, we are going to get a situation where you have a over x. So P is 0. Q is 0. So when P is 0, that's your typical x asymptote, which is the y-axis in this regard. Q is 0. That's your x-axis, also in the same breadth and in the same manner. That's what you have right there. All right. The more you do, the more you know. I've got more that's coming up. So both P and Q are equal to 0 because they are the y and the x asymptote. I think I've said this like 6 times now. All right. So guys, let's move. Let's move. So we disregard them because they are all equal to 0. All right. Let's move quickly on that one. I'm taking this out. There. The other way you could have thought about it, and it's some textbooks do show it, some don't. It usually comes all the way from grade 10. And I'll tell you this, that maths is such a progressive subject that a lot of what you learn in grade 10, you will use in grade 11, and more importantly, you'll use in grade 12. So you can actually literally use the same idea. Let me show you. If you notice a one-sided hyperbola, you can always say K is equal to XY. That's what they usually say in some textbooks. As long as it's one-sided, you can say K is equal to XY. And you want to find K first. So maybe you need to substitute. Where there's X, you'll put -1. Where there's Y, you'll put 1. So the value of K is -1. So then you bring it down here and say -1, which is K, is XY. Then you can make Y the subject of the formula. -1 over X is equal to Y. So this format is available in a situation where you have a one-sided hyperbola, a restricted hyperbola, where again, in the context of what we have, we've got our asymptotes literally as your x and y axes. So that's another way of doing it. Or you could have done the first way. Check out, especially on my grade 10 textbooks, they will show you how this is done. As long as it's one-sided and the y and the x-axis are boxing it, then you can use K is xy, where x and y is the coordinate on that graph. Get your K, then eventually it's -1, make Y the subject of the formula. Somebody says that's so easy. It's easier right there. So pretty much. So whether you use this one or the other one, you still get the same thing, right? Perfect. I'm ready for the next question altogether. Let's try another type of graph. The more we do, the more we know. There's something also I want to show you a bit later on as we are about to end, or when we're getting close to ending our lesson. It's a 2022 November, this one that I'm going to talk about. It's 2022 November. It's paper 1. And it's question number 4. Please write down the title. And maybe let's try and do it together. That way. Let's work. Let's work. All right, here we go. Sketched below is the graph of h of x is 1 over x plus p plus q. Okay. Then they say the asymptotes of h intersect at 1 and 2. And they gave us the graph, which is fine. For our first question, write down the values of P and the values of Q. 2 marks. Let's work it out together. This is a hyperbola. Every time you see an equation, please be able to identify what type of graph function that you're dealing with. Every function, and I said it in the beginning, every function has its own unique equation. Every function, its own unique equation. Lana, I am dealing typically with a hyperbola. They say to me, h of x, okay, is 1 over x plus p plus q. They said further that the asymptotes of h intersect at 1 and 2. When they are saying that, where the asymptotes meet, this coordinate is 1, 2. So they intersect right there. Fine. Write down the values of P and the values of Q. Now, notable, the P and the Q are your X and Y intercepts. That's point number 1. Let's be specific. If the format is given like this, X plus P, X plus P at the bottom right there, then you go to your graph, your X asymptote is occurring at 1, but if you put it in here, it will be X or P rather is equal to -1. Yo, say, what's happening? What's happening? Listen to me, Chuck Norris. Angithi, it's a plus. You should check textbooks and notes around this. When it's a plus P here, but when you're picking it from the typical graph, you will put it as a -1. Not a +1, but rather a -1. That's the format that we use. The Q is pretty straightforward. You take it as it is. So the Q in this case would be equal to 2. So P -1, but Q +2. So just to clarify and to add some info into this whole thing, the plus, when you pick out the value, -1 instead of the 1. Don't confuse them. Then here Q is just equal to 2. So that's my story in that regard. 4.11, please remember that. In my grade 11 weekly classes, we did the graphs. Each lesson was 2 hours. We did hyperbola 2 hours, parabola 2 hours, exponential 2 hours. We did 2 further revisions on the functions only. And all these videos are available. Available for 50 Rand per video, and it's 2 hours long. Any video of any topic you want, I got your back. Now 4.12. Bati nibona. Bati. Calculate the coordinates of the x-intercept of h. Okay, I want to rewrite h of x, and it's 1 over x, and we agreed that p is -1, so it's going to be plus -1, which is -1, then plus 2. And the question says, calculate the coordinates of the x-intercept of h. The x-intercepts are occurring when the value of y is 0. So we do maths right here. So I need to find x when y is 0. So we can take plus 2 to the other side and we transpose. That's -2. 1 over x minus 1. we can cross multiply -2 bracket x minus 1 is equal to 1. We can open the brackets, -2x plus 2, -2 times x, -2 times -1 is equal to 1. We do maths. That means -2x, if we take it to the other side, should give you -1. Dividing by -2, I get 1 over 2. So in other words, your x-intercept would occur at half and 0. It does make sense though, because if you think about it, the x-intercept should be somewhere here, where the value of x should definitely be positive, though it should be less than 1, but it is positive. So in this case, this will be your coordinate of the x-intercept. That's 4.13. I'm pulling through right there. 4.13. Write down the x-intercept of g. If g of x is h of x plus 3, write down the x-intercept of g if g of x is h of x plus 3. Now that's quite interesting. So let me work it out together with you. I'm taking this out now. Notice something. In g of x, the x-intercept that we got was half and 0. For 4.13, it says to us, write down the x-intercept of g if g of x, what is g of x, is h of x. Okay, this was h of x rather. If g of x is h of x plus 3. So that's what g of x is. It is h of x plus 3. Now, if you were to describe what happened here, when you say h of x plus 3, what literally could have happened? It means when it's plus 3, and I did say in one of my questions before, Uguti, when it's plus 3, x plus 3 in a bracket, you are moving 3 units to the left. So literally in words, you moved 3 units to the left. So your current x-intercept is here. And when you say x plus 3, you are moving, shifting literally 3 units to the left. So now you'd need to get your new x-intercept. So if anything, you are here, and then now you are moving this way. Now we need to know what the new x-intercept should be. So basically, you go to the original one, which is half, and you just subtract 3 from it. So minus 3. I know the y coordinate doesn't change, only the x is being moved. The y is 0. So your answer becomes -5 over 2. So instead of the coordinate x-intercept being here, it was shifted 3 units to the left. So you moved to the left, and probably you're somewhere here. That is your new x-intercept, h of x plus 3. Plus 3. So only the x values are affected. So when it comes to h of x plus 3, you'll see this again in the topic trig graphs, which I said is available on my YouTube channel. You're doing a horizontal shift, and this time you're shifting horizontally to the left, only affecting the x values right there. Just try 4.14 together as a team. 4.14. taking this out. Gone, gone. Boom. 4.14. The equation of the axis of symmetry of H is given by y is equal to x plus t. That's the story. The equation of the axis of symmetry of H is given by y is equal to x plus t. Let me clarify something. When it comes to a hyperbola, we do have axes of symmetry. And there's two types. There's the positive axis of symmetry. Then there's the negative axis of symmetry. Sometimes they say there's the increasing function of the axis of symmetry, which is the positive one. Sometimes they say there's the decreasing function of the axis of symmetry, which literally is your negative one. So in the exam, they usually specify, Uguti, when dealing with the axis of symmetry, this is what you are talking about. They will tell you positive axis of symmetry, ask you to write down the equation. They will tell you negative axis of symmetry. They also ask you to write down the equation, either or. In this case, what do I see? It's y is x plus t. I'll tell you this for free. This is the positive axis of symmetry. How do I know? The coefficient of x is positive. If it was a negative axis of symmetry, they would have probably written it like this, where the value of x, or the coefficient of x rather, is negative. So if it's a positive axis of symmetry, this is how it would look like, because this x, its coefficient should be positive, or you can say greater than 0. If it's a negative axis of symmetry, then its coefficient would be negative, the one for x. They asked for positive, they asked for t. Now listen to me. The y and the x values in the axis of symmetry, the y and the x values in the axis of symmetry are your asymptotes. Say that again, say. The y and x values in the axis of symmetry are your asymptotes, literally your 2 and your 1. They are your asymptotes. So the y asymptote is 2, the x asymptote is 1 plus t. It means the value of t is 1. So that's literally how you get this. And if you are asked to further write down the equation of the axis of symmetry, you write it as x plus 1. Y is x plus 1. So the y and the x are your asymptotes. I'm taking them literally from the graph, where x is the 1 and the y asymptote is 2. And that's what you get when you are dealing with this from that particular perspective. The asymptotes of x, 1, y, 2, you're finding t. So please be very careful of how specific it gets in this regard. So this is what you have for 4.15. Let's try 4.14 rather. Let's try 4.15 and see how far we can go. Somebody's asking, so why is not the x asymptote taken as negative? It's not p, it's x. If it was P, then it would be different. It's the X asymptote. It's 1. When you put it into the equation here, that's where you get your P and your Q. Those are two different things. Thank you for that question. Let me clarify this. Listen to me. Listen to me. So in essence, you are saying to me, but say, Lana, you put a negative, and Lana, it was positive. Yes, true. In the format given, it will be 1 over x minus 1 plus 2. Let's say they gave you like this, and they asked you, what are your asymptotes? You literally write it and say, the x asymptote is 1, and the y asymptote is 2, which is exactly what you're given on the graph. So that's why I said here, the y and the x are your literal asymptotes as seen on the graph. Y being 2, x being 1, t eventually after transposing giving you 1. So I hope that's okay in that regard. Let's keep working from there on. All right, let's try 4.15. Interesting question. 4.15 together as a team. Let's go. Determine the values of x for which they say -2 is less than or equal to 1 over x minus 1. Now that's interesting. That's very interesting. Now earlier on, if you think about it, the equation of h of x is literally 1 over x minus 1 plus 2. So look at what I can do. I can take this -2 to the other side. So it becomes 0 is less than or equal to 1 over x minus 1 plus 2. And this 1 over x minus 1 plus 2 is h of x. So you could write it as 0 is less than or equal to h of x. But I think you want to make your life a bit easier to understand. So listen to me. If I say to you 0 is less than or equal to h of x, you know what else I'm saying? I'm saying h of x is greater than or equal to 0. That's literally what I'm saying. H of x is greater than or equal to 0. So let me give an example. Let's just go back. Listen to me. If you say your young brother is younger than you, you are literally saying you are older than your young brother. 0 is less than or equal to h of x. Is literally saying h of x is greater than or equal to 0. That's basically what you're saying in the context of what we have right there. So in other words, we're looking for the values of x for which what? For which h of x, which is the graph given, is greater than or equal to 0. Now listen up. When a graph is greater than or equal to 0, it means that that graph is above the x-axis, literally. So say that again. Say greater than or equal to 0 above the x-axis. That's what it means. Greater than or equal to 0. So I'm going to go to my graph and look for portions where it's above the x-axis. So I look at my graph. Yebo, I'm going to shade it above, 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 and then I stop somewhere here. Then I'm going to put red for danger, below, 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 below. It's below the x-axis. check this side. This side of the graph is above everywhere. Above, 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 above. So when a graph is greater than or equal to 0, you're looking for parts of the graph where it is above the x-axis. X-axis right there. So remember the graph. See what I did with this question. We had to be clever. We would say, no, man, we can identify. We took -2 to the other side to notice that, no, this is h of x. Literally, this is h of x. And so 0 is less than or equal to h of x. That means h of x is greater than or equal to 0. What does greater than equal to 0 mean? Above the x-axis. And then I'm now dealing with parts. Okay, let me do this. Let me put pink here for above and red for below. Pink for above, red for below. There. So for which x values do we have this situation? Now listen to me. Literally, I'll speak English first, then I'll speak maths. Remember this coordinate. Its x value was half. Determine the values of x for which. Okay. So, English. For all x values, inclusive of half and before, your graph is greater than or equal to 0. In other words, all the way from half lana, before, all values, if you were to pick an x value here, if you were to pick an x value here, it will be less than half. You pick another one, the x value will be less than half. So all x values before half, inclusive of half though, because it's less than or is greater than or equal to, all of them, the graph is above the x-axis. So the graph is above the x-axis from half and before. From half and before. And so if I want to write it math, from half and before. From half and before, I would say x is less than or equal to half. From half and before. From half and before. That's my first one. So this is why you literally have to pick up and shade these particular things, whereby you are seeing that in your situation, from anything half and before, your graph is above the x-axis. All right, fine. I'm not done. We did this pink part. There's another pink part. Notice that the other pink part, the graph is still above the x-axis, and it is from 1. From 1. Now you tell me, anything after 1, and I'm speaking English, anything after 1, if you picked a coordinate here, the x-coordinate would be greater than 1. Even here, greater than 1. Anything after 1. Now I have a question. Should I include 1 or not? English, anything after 1. Anything after 1. Right there. Should I include the value 1? Because my equation, greater than or equal to 0. Should I or should I not? The answer is no, I can't. I can't include 1 because at 1, the graph is not even there. Remember, I'm looking for part of the graph where it's above the x-axis. At 1, the graph doesn't exist. It's an asymptote. So therefore, anything after 1, maths, x greater than 1, it will give you a situation whereby you've got your above the x-axis. If you would like to write it in a certain notation, you would say x is an element from negative infinity to a half with a square bracket, or you could say x is an element from one secular up to positive infinity. Both of them are secular brackets or secular brackets. So that becomes your format that you can give. I prefer these ones where you can say, oh, okay, anything before x less than or equal to half, anything after, that's x greater than 1. At 1, the graph literally does not exist. I tell you this, these questions about, hey, determine the values of x in what, everywhere. Chuck Norris, they come out every time. That's why you really need to get to know them and pull through. And I got your back as Mr. X. In fact, I've got a wall special mention question that I want to do to help us to understand these concepts of, hey, determine the values of A, those kind of things. All right. So this is a special mention question, and I'm going to use the graph on the right-hand side to actually allude to my story. So let's begin. It's quite an interesting one, so we work together step by step until we understand. So they come out everywhere, every time. In graphs of cubic graphs, that's for grade 12s, trig graphs, grade 11s and 12, functions also here. So we must know how to deal with them. So it's a special mention question. Let's get ready to roll. Talk to me. What does it say? Use the graph drawn below to determine the values of x for which, number 1, g of x is less than 0. So let's start here. G of x is less than 0. So I want to bring it up. When you say g of x is less than 0, you are looking for parts of the graph where it is below the x-axis. Less than 0 means the graph is below the x-axis. So let's look at the graphs that we have. I've got the graph of f, I've got the graph of g. And I want to shade when the graph of g is below the x-axis. Ngiyambona g. Below, 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 right there. So the graph of g is below the x-axis. But the question says, from which values of x is that happening? When does it start to become below the x-axis from what's happening? So I see, let me speak English first. English, anything before negative 2. Angithi, this coordinate is negative 2. There we are. So below, below. There you are. Yebo. Lapo. So it's negative 2. So anything below or before rather negative 2, your graph of g is less than 0. So mathematically, I would write and say x is less than 2. That would be your answer for 1.1. Any value for x less than 2, that means the graph of g is below the x-axis right there. So these types of questions are sometimes 2 marks, 3 marks, 4 marks. You have no choice but to do them. You will pass by fire, by force, but mostly by force value. That's how you're going to pass. Whether you like it or you like it a lot, you are going to pass. You are not going to waste your parents' money. That's one thing for sure. You are not going to waste your time and your future. You are going, Chuck Norris, you will pass by fire, by force, but mostly by force. Yazo, tell us force, Stella. let's force. 1.2, let's force. By force. That's how you're going to pass. Right here. We're not going to, that's not going to happen. That is not going to happen here. We're going to pass right there. All right, perfect. So it's x less than, so it's -2, sorry. There, x less than -2 in that regard. There's another one, f of x is greater than or equal to 0. F of x is greater than or equal to 0. So let's discuss that. This time we're now concentrating on the graph of f is greater than or equal to 0. Anytime you say greater than or equal to 0, you're looking for parts of the graph where it is above the x-axis. Greater than, equal to 0. We're going for f this time above the x-axis. I want to shade when x is above. Let's go above, yebo, above the x-axis. It keeps going above, and above, above and above, and above and above. Looks like to me the graph of f is above, English, between -2 and +6. The graph of f is above between -2 and +6. That's English. Now let's translate that English into maths. Between -2, I'm above. You see, one of the ways that could help you is if you could literally do this. There, and maybe that as well. So anything between -2 and 6, you get your above. So in maths, you would write it as -2 is less than or equal to x, but x is less than or equal to 6. So this is what happens when you are above. In terms of x, f of x, it's between -2 and +6. And inclusive, and the reason why I'm saying inclusive, there's this equal to sign, so less than, equal to, less than, equal to. So that's very important. Between -2 and 6, that means -2 is less than or equal to x, x is less than or equal to 6. Let's try 1.3. 1.3. F of x is equal to g of x. F of x is equal to g of x. Now, when you deal with f of x equal to g of x, you are talking about parts of the graph where the two graphs intersect. Every time two graphs are equal, we're speaking about points of intersection. The intersection of f of x with the intersection of g of x. And I think they meet at 2 points, right here and right there. The question, for which values of x does this happen? It's happening when x is -2, they meet here. X is +4, and that's where the story is. And x is +4. Every time two graphs are equal, it's because they are intersecting at those particular points right there. Let's try 1.4. 1.4, very interesting. 1.4. 1.4 says to us, f of x, okay, dot g of x is less than 0. F of x dot g of x is less than 0 right there. Now, whenever you've got a situation like this, mathematically, anything less than 0 is negative. That's the first thing. Anything less than 0 is negative. You've got f of x multiplying g of x, and we want them to be less than 0. If two things are multiplying and they give you less than 0, here's what it means. It means one of them should be positive and the other negative, or this one negative and the other positive. Plus times minus gives you negative less than 0. Minus and plus also gives you negative less than 0. So what do we need to do? We need to look for parts of the graph where f is positive. Let's start here with this one. Where f is positive, that means above the x-axis, and g is negative. That means below the x-axis at the same time. So I'm looking for a situation where f of x is above, positive, and g of x is below, negative, at the same time. Chuck Norris. Let me work. Let's start with f as positive. I'll put blue. Positive f, 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 positive f. Let's try g of x as negative. I'll use red. Negative g of x, negative g of x, below, below, below. What am I looking for? I'm looking for situations when both f of x is positive and g of x is negative. Judging by what I see, nah, this circumstance is not available. Because anytime that f of x is positive, looks like also g of x is positive. And I mean, I want positive, negative, not positive, positive. Because, beg and fetch, look at f of x here. Is positive in the blue, and also g of x is positive here in the blue. But when it's negative, when g of x is negative, also f of x would be negative. And I mean, I'm not looking for negative, negative, but rather I'm looking for positive, negative. I'm looking for blue, red, same time. Not blue, blue, not red, red. Blue, red, same time. That's what I'm looking for. So this first scenario apparently is not available. I want blue, red, not blue, blue, not red, red. Maybe let's try the second one and see if it works. This time I want f to be negative. That's below the x-axis, and I think f is negative here. And I want g to be positive. G is positive all the way there, all the way up to wherever. So what do I want? I want a situation which gives me blue and red. Blue and red. G above, F below, blue and red. It looks like that situation is actually after 6. Anything after 6, after x is 6, check. When after x is 6, f of x is negative, Naila, below the x-axis, and g of x is positive, above the x-axis. So literally, from 6, x greater than 6, your graph of f of x is negative, and your graph of g of x is positive, everything would be less than 0. So you're looking for blue and red at the same time. And that blue and red is occurring anytime after x is 6. After 6, f of x below the x-axis. After x is 6, g of x is still continuing above the x-axis right there. So that's x is greater than 6. Above, below, blue, red, at the same time. Not blue, blue, not red, red, blue, red at the same time. Work with me. Work with me. It goes further and more interesting right there. So just to clarify again, guys, f of x dot g of x less than 0 means I'm looking for two things that when multiplied give you less than 0. That's positive, negative, or negative, positive. When f is negative, it's below the x-axis, 9. When g is positive, it's above the x-axis. And I'm looking for parts when both of them are, one of them is positive and one is negative. So uchi positive lana is the blue part. So I want a part which combines red and blue. And that only happens after 6. After 6, uchi of x positive. After 6, f of x negative. After 6, g of x is above the x-axis. After 6, f of x is below the x-axis. Let's try 1.5 and 1.6 quickly. And that aligns to our story right there. 1.5 says f of x divided by g of x is greater than or equal to 0. Greater than or equal to 0. And now listen to me carefully. When something is greater than or equal to 0 and there's division, greater than or equal to 0 means positive. Now, f of x divided by g of x and is greater than or equal to 0. So here are my circumstances. I have two options. If something is dividing and gives you greater than 0, it means one of the guys should be positive and the other one also positive, or you've got both of them being negative. Literally, that's what happens. When it's f of x greater than or equal to 0, f of x over g of x there. So it's greater than or equal to 0, positive, positive, or you can say negative, negative. So this is my task. I need to look for part of the graph where f of x is positive and at the same time g of x is positive. So let me see what I can do. I want both of them to be positive. Both of them to be positive. So let's work. I can start from here. Both of them are positive. Okay, let me just put positive as blue. F of x is positive here. Positive, 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 positive. There. Now corner footed g of x is positive, positive, positive. I want blue, blue. I want blue, blue. Where do I get blue, blue? I want between what numbers? Let's speak English first. I want blue, blue, positive, positive. Between what numbers do I get that story in that instance? So between -2 and 6, I get them. But I want us to be clever when it comes to this question. -2 and 6. So look at this. Mathematics. The question says greater than or equal to 0. Now, mathematically, you cannot have the denominator equated to 0. It becomes undefined. That is not possible. Yeah. The numerator can, but the denominator cannot. So it becomes undefined if we consider ukuthi g of x, when it's positive, we include the part of 0. It won't work. It will not work. Because whatever you do, your denominator cannot be 0. So we need to be careful. While it's true, ukuthi is between -2 and 6. I cannot, for the sake of the denominator of g of x, include -2. Because at -2, the g of x is 0. And if by any chance I include 0 here, then it becomes undefined. Then the graph is non-existent. So the value of -2 must be excluded from this team. Because when it's -2, g of x is 0. So I cannot do that. Yeah, but f of x, the top guy, can be 0. It's fine, because it will literally be 0 over whatever, and it gives you 0 as well. But one thing that cannot happen is that -2 is included into the picture. Because at -2, g of x is 0. And I cannot have, by any chance, the bottom guy being 0. It's not going to work. So therefore, this is how you'd write it. It will be -2 is less than, you see, I didn't say less than or equal to x, but x is less than or equal to 6. You see, I don't mind on the 6 part, because at 6, f of x is 0, and if the numerator is 0, then everything is also equal to 0, which is fine and accommodated by my scenario, greater than or equal to 0. So therefore, -2 must not be included. It is excluded by the fact that the denominator is not supposed to be 0. Yes, the numerator can. That's why for 6 here, I said equal to. Because when x is 6, f of x wami is 0, and that's fine. The numerator can be 0, but the denominator cannot, in this case, be 0. Not even. So that's what happens right there. That's the positive. All right. I'm hoping we're getting somewhere. Let's try negative. Because I want both of them to be negative. And I want to see how that works when both of them are negative. So positive is done. Then negative, we need to work on it. So I want both graphs to be negative. So I think I'm going to do red this time, just to see how far we can go on the red part right there. This is our last question, by the way, so don't stress, we're done. It's been a wonderful time that we spent together, Mr. X, helping you. We work together. I'm going to be doing the revision classes. If you think I'm fire here, I see some of you guys like, yo, say you're fire here, say we're learning. You should see me when I'm doing the revision. You should see me when we're doing the revision, when we're now literally on fire. All right, negative. Let's work on it. So let me see when both are negative. I think it's below the x-axis. That one is for g of x, and is similarly for f of x. I want negative. So how do you think I'd write it? Negative is before -2. But again, let's be careful. We can't have a 0. We can't. So we're not. It's before -2. So we can't have a 0. So the other one should be x is less than -2 when both are negative. So we can't have it any other way. We need to make sure that it is that way. So the red is below the x-axis. So that becomes negative, excluding -2. Because guys, listen, one of the problem with -2 is that both graphs f and g are 0. And I can't have 0 at the bottom. So this is why this time I said x is less than -2. And that's basically what you have. So these are your answers or 1.5. 1.6, let's enter them. Siyabangena, we enter them. The more we do, the more we know. The less we do, the less we know. F derivative. F derivative. F derivative right there. Okay, taking this out, it's gone. Now, this section is applicable mostly to grade 12, but it's also useful for grade 10, grade 11s to learn it. So let's work it out. F derivative greater than times g of x greater than or equal to 0. Mathematically, when you say f derivative, you're talking about the gradient. That's what f derivative means. Now, when it's f derivative delta x, all right, f derivative x multiplied by g of x greater than or equal to 0, I'm looking for positive gradient of f and positive g of x, or negative gradient of f and negative g of x. These are two different things. Listen to me. When you say a positive gradient, when the derivative is positive, it means you are going uphill. So look at this. This is uphill. I'm going uphill. Means my derivative is positive. Then I'll stop somewhere here. Because after this, I go downhill, my gradient becomes negative. So every time the derivative is positive, the gradient is positive, you're going uphill. So a positive gradient means you're going uphill, and a negative one means you're going downhill. So literally, this is what I'm looking for. So downhill here. Here's what I'm looking for. I'm looking for part of the graph where I'm going uphill for f, and at the same time, I am above the x-axis for g. Because g of x is not derivative. It's just g of x. So I'm looking for the part of the graph where I'm going uphill. For f, gradient is positive. But for g, I am above the x-axis. So let me do red here. G is above the x-axis. So I want you to see what's going on. So I'm looking for positive, ne? I think it starts from, so I want positive, where the graph of f is going uphill, so which is the blue part, but the graph of g is above the x-axis, which is the red part. So I'm looking for blue and red. Blue, meaning I'm going uphill, gradient is positive. Red means I'm above the x-axis. And I think it's literally from here, -2. And by the way, this is the turning point at 2. Exactly that. So anything between -2 and +2, you are literally derivative of f of x uphill, g of x greater than 0. So my answer for this one, -2 is less than or equal to x, and x is less than or equal to 2. Because right here at this point here, that is your x value of the turning point. So it's -2 less than or equal to x, and x is less than or equal to +2. That's positive and positive. I want to try and see if I have negative and negative. Let's see. I don't think I have. Because look at it this way. Okay, maybe just to clarify that. so that it's from there. Let me clarify. Take this out. I want to see if I've got negative, because negative f of x literally means I'm going down the derivative there, and I need g of x to also be below. I don't think that can happen. So because every time that this guy goes down, g keeps going up. G is positive. So I wanted negative, and you won't get it in this scenario. So your only answer would actually be this one, which accommodates the positive. So that becomes your answer from there on. That's your idea. That's everything that we need to do in terms of what we needed to understand today. Obviously, guys, there's more questions, there's more stuff. I'll be able to do some other free classes, but I do not want to forget the most important thing that's happening starting from the week that we're coming to. Maybe someone is still writing. All right. I do not forget what is very important, the revision classes. Somebody says, I'm coming for the revision. And I hear the kind comments say you made things so simple. You're very welcome. This was a wonderful class. Thank you, sir. And I see the YouTube family also. I apologize for not being able to answer all your questions at the same time. But I'm hoping that you understood some stuff that I taught. And the most important thing is what's coming in the next coming week, Monday the 2nd of June, Sunday the 8th of June. We are doing mathematics revision. You are doing with me 10 hours. It's going to be divided into 5 hours. The first session, 4 to 9 p.m. That's Monday the 2nd. The second one, Sunday the 8th, 2 to 7 p.m. And for 10 hours, it's 200 rands. That's mathematics. I'm going to do something similar for physical sciences, Wednesday the 11th of June, Monday the 16th of June. And these are the topics and others that I will do. I also will do some grade 11 revision. I will be updating you guys on when and writing down through and all. For those that are not in my WhatsApp groups, I'm typing my number on the chat. I'll say it out for those on YouTube, 073 974 8498. Right here. That will be the number. Send me a text. I'll put you into the groups if interested in the revision classes, which will save your life. Baba, it will save your life. Right there. Come through at a cheap price of 200 rands for 10 hours. It's as good as paying 20 rand an hour. That's not even enough to buy McDonald's. All right. Somebody says, one day when I'm big, I'll buy you a Ferrari, Mr. X. I'm holding you to that. I'm holding you to that. 073 974 8498. I'll also put it in the chat on our typical YouTube page. 073. There you are. That's what you have from there on. Thank you so much for joining today's class. I really appreciate your presence here. Do not forget that also on a weekly basis, I do these classes. So I'm going to continue with them. After we're done with the revision, sometime in July, we're going to start off our, end of June, we're starting off our more classes where we do more topics. As you can see, chemical equilibrium, acids and bases, that's for physical science, trig functions, application to calculus, finding the equation, all these different things that are being done with Mr. X. These classes, the weekly ones, are from 7 to 9 p.m. and they take place every typical Monday for grade 11s, that's maths, Wednesday, physical science, grade 11, Tuesday, maths, grade 12, and Thursday, maths, physical science, grade 12. 250 rands per month, per subject. It'll give you access to 5 lessons from there. Thank you. It's been amazing as always. I'll stop the recording and I will also take out the live. For those that are on the live in our Zoom, in our YouTube, I'm going to send you the Zoom link in case you want to come through and discuss, because we're just gonna have a bit of a chit chat after this for like 3 minutes or so. Then after that, I'll close off the meeting. Then we can go to our respective places. Just want to find out what's happening. I'm going to send the Zoom link for those on the live on YouTube. There you are. I've sent it. You should be able to get it. And then I'm stopping the recording.